Hi, I'm Mark at Combustion Technologies. We're going to take a tour on how a piston is made here. Come with me. As you can see, we're out here in a rural countryside of Virginia. There's 5 people work here in addition to me. I started the business back in the mid-80s. And when I started the business, we were just manufacturing piston rings. And then in the mid-90s, we started manufacturing pistons. And at that time, we were just manufacturing aircraft pistons, primarily for the Pratt Whitney market, which is, this is here is a forging actually for a Pratt Whitney piston. This is the first piston we ever made here. This is the forging for it. It's for a Pratt Whitney R1340 engine. This is a 5 3/4 inch bore. You can see it's pretty large forging. This here is a forging for a angle valve Lycoming piston, which we're going to take a look at inside in a minute, because we're making these right now. And what we do in here is, this is where all our material is stored, and spare packaging supplies, and each forging lot that comes in is assigned a lot number. And that way we can trace back through our system what happened with that material, what parts were made from it, who made the parts, who did what to the part on what day, what the chemical composition of that particular lot was, what the mechanical properties were. So if there's ever a problem, because this is an FAA facility, FAA approved facility, if there's ever a problem with, when we have to recall something, or if there's a question about quality, we can go back and pull up the records and know what happened on that particular piston that's in question. So typically all the materials start down in a material shed, and when we issue a job for production, we actually issue a printed traveler that travels with the parts. This is the same forging that I showed you down in the shed that's been pulled for production. And this is the same forging with the first operation done. The valve release has been cut, the outside diameter has been roughed out. We're doing that in this machine right here. It's actually cutting the valve release right now. This is a mill turn machine, so it does milling and turning in the same machine. This allows us to have very tight relationships between the geometries on the piston. And that's one of the things that a lot of people that use pistons don't realize, that the most important aspect of a piston is how the geometries of the piston relate to each other, not necessarily just the width of the ring groove or the diameter of the pin bore, but how those features relate to the skirt of the piston and to the other ring grooves and that kind of thing. So because we do it in this manner, the part that goes from here into here, this whole piston is made with 4 setups. You have one setup in here. Next setup is in here, where it's going to do the pin bore work. It's going to cut the bottom of the skirt. It's going to finish doing some turning on the outside, which is what it's doing right now. It's going to rough out this groove and put some drain back holes in it. So because we can do milling and turning in the same machine, we end up with a much better quality product. So Jason's doing some deburring operations. In between each operation, the piston is weighed so we can control the finish weight pretty close. There's a bunch of aspects of the piston you can inspect at the machine. He also checks them on the CMM to make sure that what he's checking out here correlates with what the CMM is checking. The coordinate measuring machine, or CMM, we use as like an independent inspector to verify that what is being made is actually correct. After they're done in here, they're going to come Back into here to get finish turned. This is actually a Pratt Whitney piston, so this is a different application than what we looked at previously. These pistons are round when they're done, so they don't have to get cam turned after the fact. The pistons that we looked at previously, those have to get cam turned, which is an extra process. So this piston's actually made 3 setups, whereas that one's 4 because it's an extra process for the cam turning. As you can see, Mike was miking up the piston. But that same feature would be checked on the coordinate measuring machine. Not every part, but a sample of parts from each production lot. And those are the records that we keep, so that we need to look back to see what the inspection records were for a particular production lot. We can easily look that up. I think, Mike, you're getting ready to finish turn one? So after they're done in here, they will go and get washed. And then after washing and weighing, pistons are sensitive to weight. So the weight of the piston has to be controlled within a certain limit. Some pistons have tighter limits than others. It depends on the application. But these are essentially all done through production except for marking. And that's what this station here is for, the final marking. So the piston will get a visual inspection to make sure everything's deburred. There's no chips in the ring grooves. There's no obvious forging defects. And the people there's only a handful of personnel that are cleared to do this process. It takes years of experience before you know what to look for on a finished piston. So this is going to laser mark the part number, FAA, PMA, and the part number, and the production number onto the piston, so that there is traceability throughout. So when somebody gets this part a few years from now in an engine and they want to know who did it, what was done to it, where the material came from, we can look that up in 5 minutes. Over here we're running some NASCAR parts. We've been manufacturing parts for top level NASCAR for about 20 years. This is also a mill turn center that is doing all the milling operations for NASCAR part. We don't really show a lot of what's going on here because we have some input into the design, but we don't want to give away any secrets that our customer doesn't want given out. So as you can see, we install a robot that will attend to this machine. So now we're in the inspection department. Mike is going to run a final turning inspection on a part he just turned that you saw being turned earlier in the video. This is a coordinate measure machine. What it does is it triangulates points. So once it gets started, it's going to start taking points. And every time you hear it beep, it's recording the location in X, Y, and Z of that point. So that was 1 point. Here's another point. So it's going to take 3 points on the bottom of the part. So from those 3 points, it can construct a plane. Right? Now it's taking points inside the pin bore, and it's going to take, I don't know, maybe 8 points inside the pin bore, and from those 8 points, it can construct a circle. And it's going to come over to this side, and it's going to do the same thing on this side. So you can have a circle on this side, a circle on the other side, and from those 2 circles, you can construct a cylinder. So now what we're doing is we're constructing geometrical shapes. And in a coordinate measure machine, with these geometrical shapes, you can report the relationships between those shapes. And this is where the quality of the piston tells the story. So the CMM is telling you whether or not these relationships between the geometries is correct, which you can't do just by inspecting the size of the pin bore. You can measure the size of the circle, but that doesn't tell you how that circle sits in, say, the cylinder of the skirt itself. Because the cylinder the skirt goes into a cylinder. So we're constructing a cylinder of the skirt and comparing the cylinder of the skirt to the cylinder of the pin bore. And not just that, but also how the plane of the ring grooves. So the ring grooves make up a planar surface. And if you have a planar surface that's tilted like this in a cylinder like this is not going to work. You're going to have problems with piston ring sealing. Now this piston's unique in that it has the 5, actually it holds 6 piston rings. There's 3 compression ring grooves. There's an oil control ring groove, which actually holds 2 rings in that groove. Then you have an oil scraper groove at the bottom. And these compression ring grooves are all full keystone grooves, which means that the top and the bottom of the groove are angled. They're like splayed out like a keystone. You see a keystone at the top of an arch? Same kind of concept. So we check the surface finish of the pin bore, surface finish of the skirt. On some pistons, we check the surface finish inside the ring grooves themselves. This is our shipping room. You can see this is the piston that we were showing you the production of. This is a finished one here, ready to get shipped out. It's weighed. We should mark the weight on them. It's marked with the part number and FAA PMA. So this is an FAA approved piston. We also marked the weight on the outside of the box. So you got 1330. These are all the same weight here. Then you got 1331. So all of these are within 1 gram. So when somebody says, hey, can we get a balanced set? Typically we can come out here and give them a set of 4 or 6 that all weigh exactly the same. So what happens is when you order through our website, we'll get an email. I'll either get the email, usually Jason will get the email. This is Jason. What do you want to say? Jason's going to get the email, make sure we got the parts in stock, package them up, and get it shipped to you out. Usually the same day. If the order comes in, say by what, 2, 3 o'clock in the afternoon, it'll go out the same day if we have them in stock. And the website will say we have them in stock. If they're not in stock on the website, that means they're not in stock here. If they're in stock on the website, that means they're in stock here. So thank you all for checking out the video. If you have any questions, you can contact us through the contact information on the website, combusttech.com. Thanks.